This is Math 131, section 11.3. This will be the last section we work on. We won't do section 11.4. Okay, so we'll just talk about some terms first. First of all, an investment is the use of money or capital. Sometimes we say capital for money, for income or profit. So if you have money invested, you're giving your money for someone else to use, but you make money from doing that. Okay? And then there's certain security that you can, you'll get the money back, right? Okay. In a fixed investment, the amount invested as principal is guaranteed, and interest is computed at a fixed rate. Okay, so you get a fixed rate of interest, and they tell you like maybe it's 4% per year or something like that. Okay. On a variable investment, neither the principal nor the interest is guaranteed. Okay, that's much more risky. However, usually if you have a variable investment, you get much higher returns. You can think of like stocks as being like a variable investment, but bonds might be a fixed investment. You don't get as high returns with a fixed investment, but it's safer. Okay. Okay, now let's talk about compound interest. If you put your money in a bank, they don't pay simple interest, they pay compound interest. So what they do is they take the interest that you earn, let's say for the year, and they put it back in your account, so now you have extra money. And then next year you earn interest on that additional amount too, plus the amount you have in the account. So what you're doing is you're accumulating, money by putting the interest back in. We call that compound interest. Okay. So compound interest is interest that is computed on the principal, what you put in your account, and any accumulated interest, any interest that you've earned, okay? And that gets put back in the account. So it's not like they send you a check for the interest, they throw it back in your account. And that's how compound interest is calculated, using that amount, extra amount. Okay, that gives us our compound interest formula. A equals P times 1 plus R over N, where R over N is a fraction, to the N times T, where N times T is a decimal. Okay, so first of all, let's talk about the terms. A is the amount that accumulates in the account. So how much money you have in the account after a certain time. P is your principal. That's how much you invested. Okay. R is your annual interest rate as a decimal. Okay, so make sure if it's 6%, we write it as 0.06, etc. T is our time in years. And N is the number of periods per year that we compound interest. Okay, so it's the number of compound periods per year. Okay, so that's how we get this formula. A equals P times 1 plus R over N to the NT. Don't worry about how we derive this, but basically, I'll kind of show you in class, but basically you're going to multiply times 1 plus R every year, and you're going to multiply times 1 plus R over N every period to get, what's in your account when you calculate the interest. That accumulates the interest and adds it to your account. Okay, and I'll show you how we do that in class, but just follow this formula, and you don't need to memorize this. I will give this to you, this compound interest formula, on a test. You just have to know when to use it. Okay, so let's say someone invested $3,000 in a savings account, interest rate of 1.8% compounded monthly. Now this is an annual interest rate when they say interest rate. Okay, so we're going to do 1.8%, but we're going to compound it monthly. Okay. So she makes no other deposits into the account. Determine the amount in the savings account after 2 years. Okay, so we got to think of what our numbers would be here. Okay, so P is 3,000. It's the amount we put in the account, how much we invested. R is 1.8%. So again, we write that as a decimal, so we write it as 0.018. N is the number of periods we do per year, so this is monthly, so we're going to do 12. And then T, we're going to look at 2 years. So we're going to use these numbers and follow the formula to get our calculation. Okay, P is 3,000, R is 0.018, 1.8% is a decimal. N is 12 because we're doing it monthly, compounding monthly, so 12 times per year. And we're looking at 2 years, so T equals 2. Okay, so using the formula, A equals P times 1 plus R over N to the NT. 3,000 goes here. 1 goes 1. R becomes 0.018 here. N is 12. And NT is 12 times 2. That's not 12.2, but 12 times 2. So we get 3,000 times 1 plus 0.018 over 12 to the 12 times 2, or 24. Okay, we do that calculation inside the parentheses. We get 1 plus our fraction gives us 0.0015. to the 24th power, and then this is just 1.0015. So on a calculator, we would do this first, 1.0015 to the 24th, using our exponent key, and I can show you that in class, and then multiply times 3,000. So we do this 1.0015 to the 24th, we get this, multiply times 3,000, we get $3,109.88. So that would be the amount in the account after 2 years. Okay. Make sure you round to the penny or to the hundredths place, because when we talk about dollars, we're going to go to the cent, round to the cent. So go to the second decimal place for all money calculations. Okay, let's talk about annual percent yield, or APY. Okay. Sometimes we call that effective annual yield or annual percent yield. So you'll see that on accounts sometimes. It's kind of the equivalent simple interest rate. It's a simple interest rate that gives the same amount of interest as a compound rate over the same period of time. So it would kind of say, if we did our compound calculation, and then we wanted to look at, well, what if we just did simple? What simple interest rate would give us that same money? Would give us the same money. So that's kind of what we're doing with annual percent yield. Okay, now let's talk about the present value formula, which is kind of a variation on our compound interest formula. In fact, it is the same formula, but we just rearranged things a little bit. We solved it for P. Okay. Now, what we're going to do is we want to see how much we want to invest now. So we're going to call P our present value, or how much we want to invest now, to get some accumulated value, A, in the future. Okay, where R is our annual interest rate as a decimal. Again, N is the number of compound periods per year, and T is the time in years. So nothing's changed as far as these letters. They're still, this is the amount that we're going to invest now. This is the amount that we'll have in the future. And then this is our interest rate, how many times per year, and T will be number of years. So let's say we want to have, $1 million in 10 years. This would tell us how much we'd have to invest now to get that. Okay, so it kind of gives you, what you need to put into your account right now if you want to earn, have a certain amount of money later in the future. Okay, it's called our present value formula. Okay, so let's look at an example. Will Hunting would like his daughter to attend college in 6 years when she finishes high school. Okay, he would like to invest money now in a certificate of deposit, or CD, to pay for his daughter's college expenses. He estimates that he will need $30,000 in 6 years. Okay, how much should he invest now in a CD that is a rate of 2.5%? Now that's an annual rate, compounded quarterly. Okay, so we want to know, he's going to want his A, we want it to be 30,000. His R will be 0.025. His N will be 4. Okay, and then we will figure out what the P will be, which means, and T is 6. We figure out what the P will be, how much he has to put away now. Okay, so this is the amount that he wants in the future. The A, this is 1 plus R over N to the N times T. R over N was interest rate divided by 4. Okay, plus 1, and then N times T, it was 4 times 6, right? It was 24. So 30,000 divided by 1.161232. So he needs to invest about $25,833.30 to get $30,000 in 6 years if we do 2.5% 4 times a year. Okay, so it's just a variation on what we did with compound interest, except now we're going to find the P instead of the A. Okay, so we move the equation around a little bit. Okay, so I'll show you an example in class too, and how we did that, manipulated that equation to get the present value one.